A is the
Okay.
inverse of matrix A inverse. So 8 is a number. The reciprocal of 8 is 1 by 8. And reciprocal of 1 by 8 is 8. Similarly, in matrices, we don't have reciprocals. Like we have the reciprocals, but we call them inverses. So if I have a matrix A, the inverse of A is A inverse. I will write it like this. I will put a small negative sign at the top of A. And inverse of A inverse, the inverse of A inverse is A. Did you understand it?
Okay.
So instead of writing, if I have a matrix A, I will not write A 1 by A. I will not write the reciprocal like this, 1 by A, like we write in numbers. Why? Because in matrix 6, we do not divide by a matrix. We don't divide by a matrix. So in the matrix, what we do, we write A. The inverse of the matrix is going to be A inverse. So the reciprocal of the matrix is going to be A inverse. We are not going to write this. No, we will write like this. Clear?
Okay.
Okay. Now, if you multiply a number with its inverse, what do you get?
1.
Very good. If you multiply 8 with its reciprocal 1 by 8, you get 1, which is the identity number. Similarly, if you multiply a matrix with its inverse matrix, what you're going to get? You are going to get an identity matrix. So I stands for identity matrix.
Okay.
Is it clear? So
Yeah, I understand.
when you
It's
multiply a number with a reciprocal, you get 1, which is identity. And when you multiply a matrix with the inverse matrix, you get an identity matrix. Now tell me, what is an identity matrix? Can you write a 2 cross 2 identity matrix over here?
okay. So it's like 1 0 0 1.
Can you
Like
write a
this.
3 cross 3 matrix, identity matrix?
That is 1 0 0 0 1 0 0 1. Like this.
All right. So you can see that identity matrices are square matrix. All of the identity matrices are square matrix because they contain equal number of rows and columns. Equal number of rows and columns. Clear?
Okay.
So identity matrices are equal square matrices.
So
So
if it's not a square matrix, it's
yes,
not called an identity matrix.
it's not.
So if it's not gonna be called an identity matrix if it's not a square matrix.
No, identity matrix is always going to be a square matrix. If it's not square, it's
Okay.
going to be identity.
Okay.
Identity matrix has 1 in diagonal. So diagonal element is always going to be 1. So let's check this. You can see diagonal elements are always going to be 1. And rest of all the elements are going to be 0.
Okay.
Correct? So what is an identity matrix? A matrix in which the diagonal is 1, but rest of all of them are 0. Okay. So identity matrix we represent it by capital letter I. It has a symbol capital letter I. So when you multiply inverse matrix with its inverse, you get an identity matrix. For example, A multiplied with its inverse, or A inverse. If you multiply matrix A with its inverse, what do you going to get? Identity matrix. If you multiply A inverse with A, what you're going to get? Identity matrix. So we can write it that A inverse is equal to A inverse A is equal to the identity matrix. Is it clear?
Okay.
Okay.
Yeah.
Now we are going to learn that how to calculate the inverse of a matrix. This is, we already learned that when we multiply our matrix with its inverse, we do get an identity matrix. But now we need to learn it how to calculate identity matrix. Okay, so let's suppose I have a matrix A, B, C, D. This is a matrix, genuine matrix, and I want to calculate the inverse. So what I have to do?
So that would
1
be
by multiply first and fourth, cross multiply AD minus BC. Is the first step clear?
okay.
AD means multiply like this and this. AD minus BC. So always minus is going to come in between, and always it will be 1 by, because it is the formula. After doing that, you just multiply it with a matrix, and that matrix should contain just shift the positions of A and D. So D comes at the top and A comes at the bottom. And shift the signs of C and D. So they were both positive, so they both become negative. Shift the positions of A and D. Shift the signs of, this is going to change the position, and these are going to change the signs.
Okay.
Okay, let's do it with the help of a actual example. 4, 2, 7, 6, and you need to find inverse. So step number 1 is 1 by. Now multiply 4 times 6.
So that's 20. So that's 24. 24. Minus this, which is minus 14. Okay, so that's 1/10.
Okay. Now swap the
So
position of 4 and 6.
so 6 goes. So I mean 6 is here, 4 is here,
And
and we have to
swap the
switch the
sign.
sign. So this is -2, -7.
All right. So what is 24 minus 14?
10. So it's 1/10.
10. 110? No, only 1 by 10.
Oh
Okay.
yeah. So no, the whole thing is 1/10.
Okay, write it down. Write it here.
Yeah. 1
Okay.
over
Now
10.
you already know the scalar multiplication. That 1 by 10 is multiplied with the matrix. So how to multiply it? Multiply each element with 1 by 10.
So that'd be
You multiply each element with 1 by 10. Okay? This is
okay.
multiplication if you know that. Okay. So whatever the scalar multiplication, what we do, whatever number we have over here, we multiply it with each element. So I multiplied 6 with each 1 by 10 with each element. So what is the new matrix that I will get?
That's 0.6, -0.7, -0.2, and 0.4.
In the last class, you learned about matrix multiplication. Now you're just going to check what happened. So this is the inverse of the matrix A. This is, you find the inverse. This is the inverse. Okay, we're done. Now what was the actual matrix? The actual matrix was 4, 2, 7, 6. And we multiplied the actual matrix with its inverse. So what was the inverse? 0.6, -0.2, -0.7, 0.4. So you multiply a matrix with this inverse. Now I want to multiply both of them.
Okay. So that is so it's first this. So that's 4 times 0.6 plus 7 multiplied by negative 0.2. That's the first one. Then it's 2 multiplied by 0.6 plus 6 multiplied by negative 0.2. Okay, then the second row is 4 multiplied by negative 0.7 plus, so it's 7 multiplied by 0.4. And then here it's 2 multiplied by negative 0.7 plus 6 times 0.4. Simplifying it, I'll just do it on a calculator. So that's
Yes.
4 multiplied by 0.6 multiplied by so 4 times 0.6 is 2.4. 7, so it's 7 times 0.2 is minus 1.4. Oh, which is just 1. And then 4 multiplied by negative 0.7 is 2.8, negative 2.8 plus 2.8, so that's 0. 2 times, that's 1.2 plus negative 1.2 is 0. 2 times negative 0.7 is 1.4 negative plus 2.4, which is just 1. Oh, so it's the identity.
Okay, so did you observe that what we learned was actually correct? And what we learned was that when we're going to multiply a matrix A with its inverse. So what was the matrix A?
Matrix A was where
Matrix
it was here.
A,
It was here.
and this was the inverse that you calculated. So when you multiply, this was matrix A and this was A inverse. When you multiply A with A inverse, you can see this is A with A inverse. What do you get? Identity. So this is what we learned, that when you multiply A with A inverse, you are going to get identity. So this is true. This is true in all the cases. Okay?
Oh, okay.
This is what I'm trying to make you prove. Did you understand it, Nabita?
Yeah, I understand it.
Matrix with its inverse, you are always going to get identity. Now you can also prove this thing that if you multiply the inverse of a matrix with the matrix, what happens? So what was the inverse of the matrix? 0.6, negative 0.2, negative 0.7, 0.4. Opposite happens. And 4, 2, 7, 6. If you just make them opposite, write A inverse first and A afterwards, then what will happen? Will you still get an identity matrix?
I think so.
You want to check this?
I think so.
Okay, check this. Just quickly check this with a
Okay.
calculator help. Okay.
So that's 0.6 multiplied by 4 plus uh so that minus 0.7 multiplied by what's this row? So that's 2. The next then this side it's minus so that's times 7, then negative 0.7 times 6, and it's here it's this is 2.4, so which is just 1. 4.2 minus 4.2 is 0. Oh, so it is an identity matrix.
So you see either in both the ways, A and A inverse or A inverse and A. You are always going to get the identity matrix when you multiply a matrix with an inverse. Okay?
Okay.
Okay, I hope this is clear. Okay. Okay, so this is a few questions related to inverse matrix.
Okay.
Can you see question number 1? Okay, start finding the inverse for this.
Should I do number 1? Okay, so that's the formula is okay. So it's 1 over. So it's this. So it's -9 times -2, which is 18. 18 minus -9. -9 times -2 is 18. Wait, you can't. Wait, it can't divide by 0. Wait, how do you do this one?
So you get 0. So in this case, you will write inverse do not exist.
Oh, okay.
Whenever you get 0 over here, it means inverse do not exist.
Okay, I'll do number 2 then. So I'll write the. So then it's -2 times 1, which is -2. -2 minus -6 times -1, which is -6. So it's plus so that's negative 1/4. So I need to multiply this whole thing by 1/4. I'll just write the, okay, so it's 1/4 times negative 2, which is negative 2/4. Then 1/4, negative 6/4, and 1/4. Do I need to simplify the fractions, or is this fine?
Oh, it's fine. But you need to multiply this 1/4 with every element.
Yeah, I did. It's negative 2 times 1/4.
Period.
So that's negative 2/4.
So remove it from here now. Okay.
Yeah, so this is the,
Next.
okay, so I need to multiply everything by 4 times 6 is 24. 5 times 9 is 45, which is 1 over negative 1 over negative 1 over, okay. Well, I believe that's right. Okay, so I'll just do improper fractions then. So that's negative 4 over 21. 5 over 21. I'll just make this a little bit bigger. Okay. 9 over 21. Then 6 over negative 21. 6 over negative. This is the inverse.
How do you find the inverse?
Huh?
I think you're doing some mistake. Did you change the positions of 4 and 6?
4 times 6 is
No,
24.
change the positions over here. See,
Huh?
wait, let me tell you. There is one mistake you did.
Oh.
See, it's 1 by negative 21. You will multiply it with, now you will change the positions of 4 and 6 and change the signs of 9 and 5.
Oh.
Now
Okay.
it's multiply. Okay?
Oh wait, I'll redo question number 2 as well then.
No, leave 2. Come to the next one now.
Oh, okay.
Come to number.
Wait. I'll erase what I wrote here now.
Did you get it?
Okay, I understand. Okay, so it's still 1 over negative 21.
Yes. Write the matrix.
Then so now I have to multiply it by 6 here and 4 is here, and it's positive 5 and positive 9. Okay, now I'll multiply
Yeah.
it. Okay. So now the inverse is 6 over negative 21. Then 5 over negative 21. 9 over negative 21. negative, then 4 over negative 21. That's the matrix. That's the inverse.
Yes, now it's fine. Come to next one.
Okay. So 1 over 0 minus 0. So there's no inverse for this one. There is no inverse for this one. Hello?
Yes, yes.
There's no inverse.
Come to question number 5.
Okay. So uh negative 11 minus negative 10, so plus 10. So that's just 1 over negative 1. So the negative 1 goes up here, 11 goes here, negative 2 and 5. Okay, so that is that's just negative 1 divided by 1 is just 1. Negative 5 over 1 is negative 5. Negative 2 over negative 1 is 2. Then negative 11. Okay, so number 6 is 1 over 0 minus 3 is. Okay, so then that would be. So we switch these, so it's negative 9 here, and 0 goes down here. 1 and 2 like this. Okay. Negative 9 over 3 is 3. Negative 1/3. Oh, yeah. So just, yeah.
Uh, did you get 3 over here?
Wait, isn't it negative 9 over negative
So
3?
find the determinant again.
Okay, so this is 0, 0 multiplied by negative 9, which is 2. Oh, wait, no. Oh, this is 2. This is minus 2. Okay, wait. 0 is still correct, so that's negative 9 over 2, which is straight 9 over 2. Then negative 1/2. Negative 1/2.
Come to the next one. Question 7 and 8.
7. Okay, so that would be 1 over 1. Negative 1 times 7 is negative 7. Negative 7. So that's just plus 7. So that's just no inverse. No inverse.
Okay.
Which one should I do?
Continue to number 8.
Okay, so that's 1 over negative 3 minus 6, which is 1 over negative 9 multiplied by okay, so this is negative 9, so that's this is also negative 9 here. Like this.
Come to question number 9.
Okay, so that is that is 18 minus 8 would be what? Negative 26. Okay.
Can you recheck the determinant?
Oh wait, 18 minus. Oh wait, no. Oh wait, it's 10. Not. I was thinking negative 18. Wait. So that's just And okay, wait, let me okay, so the determinant is 1/10. 1/10, so it's 6, 3, 2, 4, like this. Okay, so that's, I'll just do decimals, so that's 0.6, 0.2, 0.4, and 0.3.